The second problem involves finding the mass of a person on Earth who has a weight of 450 newtons. So we are looking for mass. We want our weight of 450 newtons, and because we're on Earth, by virtue of being on Earth, we get gravity. So even though that number isn't listed, we get to use it. So our given information, we have a weight, and that's equal to 450 newtons. And we also have gravity, and that's 10 meters per second squared. Our unknown mass, find the, or what is the, that means that we don't know that. I come up to my triangle. If I cover up the mass, because my equation is going to start m equals, the position of the variables is going to be stacked like a fraction, or I'm going to be dividing. So I'm going to take my weight and I'm going to divide it by my gravity. So mass is going to equal 450 newtons, and I'm going to divide that by my 10 meters per second squared. Now the number part here is easy to resolve. 450 divided by 10 is going to be 45. The unit part, we've got a newton and we've got meters per second squared, and we can't leave that unit like that mixed. It's not simplified in the solution. So we're going to substitute in a newton is equal to a kilogram meter per second squared. We're going to substitute in kilogram meter per second squared, and we're dividing it by meter per second squared, meaning those can cross out, and that means that we're going to be left with 45 kilograms. Our last check should be, is kilogram a unit of mass? And it is, so we should feel reasonably certain that we've arrived at the correct solution.